Appendix B Kubernetes in production with DigitalOcean. This chapter covers running a Kubernetes cluster on DigitalOcean, running a PostgreSQL database on DigitalOcean, running Redis on DigitalOcean, running RabbitMQ using a Kubernetes operator, running Keycloak using a Helm chart. Kubernetes is the de facto standard for deploying and managing containerized workloads. We've been relying on a local Kubernetes cluster to deploy applications and services in the Polar Bookshop system throughout the book. For production, we need something else. All major cloud providers offer a managed Kubernetes service. In this appendix, you'll see how to use DigitalOcean to spin up a Kubernetes cluster. We'll also rely on other managed services provided by the platform, including PostgreSQL and Redis. Finally, this appendix will guide you through the deployment of RabbitMQ and Keycloak directly in Kubernetes. Before moving on, you need to ensure that you have a DigitalOcean account. When you sign up, DigitalOcean offers a 60-day free trial with a $100 credit that is more than enough to go through the examples in Chapter 15. Follow the instructions on the official website to create an account and start a free trial. See this link. Note: the source code repository accompanying this book contains additional instructions for setting up a Kubernetes cluster on a few different cloud platforms in case you'd like to use something other than DigitalOcean. There are two main options for interacting with the DigitalOcean platform. The first one is through the web portal, cloud.digitalocean.com, which is very convenient for exploring the available services and their features. The second option is via Doctal, the DigitalOcean CLI. That's what we're going to use in the following sections. You can find instructions for installing Doctal on the official website. See this link. If you're on Mac OS or Linux, you can easily install it using Homebrew.
See this code.
You can follow the subsequent instructions on the same Doctal page to generate an API token and grant Doctal access to your DigitalOcean account. Note: in a real production scenario, you would automate the platform management tasks using a tool like Terraform or Crossplane. That is usually the responsibility of the platform team, not of application developers, so I won't add extra complexity here by introducing yet another tool. Instead, we'll use the DigitalOcean CLI directly. If you're interested in Terraform, Manning has a book in its catalog on the subject, Terraform in Action by Scott Winkler. See this link. For Crossplane, I recommend reading Chapter 4 of Continuous Delivery for Kubernetes by Mauricio Salatino. See this link. Section B.1 Running a Kubernetes Cluster on DigitalOcean. The first resource we need to create on DigitalOcean is a Kubernetes cluster. You could rely on the IaaS capabilities offered by the platform and install a Kubernetes cluster manually on top of virtual machines. Instead, we'll move up the abstraction staircase and go for a solution managed by the platform. When we use DigitalOcean Kubernetes, see this link, the platform will take care of many infrastructural concerns so that we developers can focus more on application development. You can straightforwardly create a new Kubernetes cluster using Doctal. I promised that we would deploy Polar Bookshop in a real production environment, and that's what we'll do, although I won't ask you to size and configure the cluster as I would in a real scenario. For starters, setting up a Kubernetes cluster is not a developer's responsibility. It's a job for the platform team. Second, it would require more in-depth coverage of Kubernetes than is provided by this book to fully understand the configuration. Third, I don't want you to incur extra costs on DigitalOcean for using a lot of computational resources and services. Cost optimization is a cloud property that applies to real applications. However, it might become expensive if you're trying things out or running demo applications. Please keep an eye on your DigitalOcean account to monitor when your free trial and $100 credit expire. Each cloud resource can be created in a data center hosted in a specific geographical region. For better performance, I recommend you choose one near to you. I'll use Amsterdam 3, AMS3, but you can get the complete list of regions with the following command.
See this code?
Let's go ahead and initialize a Kubernetes cluster using DigitalOcean Kubernetes, docs. It will be composed of 3 worker nodes, for which you can decide the technical specifications. You can choose between different options in terms of CPU, memory, and architecture. I'll use nodes with 2 vCPU and 4 GB of memory.
See this code?
Note: if you'd like to know more about the different compute options and their prices, you can use the doctail compute size list command. The cluster provisioning will take a few minutes. In the end, it will print out the unique ID assigned to the cluster. Take note, since you'll need it later. You can fetch the cluster ID at any time by running the following command. I have filtered the results for the sake of clarity.
See this code?
At the end of the cluster provisioning, Doctal will also configure the context for your Kubernetes CLI so that you can interact with the cluster running on DigitalOcean from your computer, similar to what you've done so far with your local cluster. You can verify the current context for Kubectl by running the following command.
See this code?
Note: if you want to change the context, you can run kubectl config use context name. Once the cluster is provisioned, you can get information about the worker nodes as follows.
See this code?
Do you remember the Octant dashboard you used to visualize the workloads on your local Kubernetes cluster? You can now use it to get information about the cluster on DigitalOcean as well. Open a terminal window and start Octant with the following command.
See this code?
Octant will open in your browser and show data from your current Kubernetes context, which should be the cluster on DigitalOcean. From the upper right menu, you can switch between contexts from the drop-down box, as shown in Figure B.1.
Figure B.1. Octant lets you visualize workloads from different Kubernetes clusters by switching contexts.
As I mentioned in Chapter 9, Kubernetes doesn't come packaged with an ingress controller. It's up to you to install one. Since we'll rely on an ingress resource to allow traffic from the public internet to the cluster, we need to install an ingress controller. Let's install the same one we used locally, Ingress Engine X. In your Polar deployment repository, create a new Kubernetes platform production folder and copy over the content from the Chapter 15/15n/Polar deployment/Kubernetes/platform/production folder in the source code repository accompanying the book. Then open a terminal window, navigate to the Kubernetes Platform Production Ingress Engine X folder in your Polar deployment project, and run the following command to deploy Ingress Engine X to your production Kubernetes cluster.
See this code?
Feel free to open the file and look at the instructions before running it. Note: you might need to make the script executable first with the command chmod +x deploy.shi. In the next section, you'll see how to initialize a PostgreSQL database on DigitalOcean